Hello, my dear students, all my dear first PUC science students. How are you all doing? Yes, I hope you're going well. All your studies, your college, everything, right? So, organic chemistry, some basic principles and techniques is a first organic chemistry chapter in your first PUC chemistry, right? So this chapter you know very well that it deals with all the organic chemistry basic terms that is very much necessary for your further studies in organic chemistry. So students, in today's session, it is definitely going to help you in all the ways. I have brought in front of you all the important topics, especially 2 marks important questions that you can expect from this chapter. Okay, how it is gonna help you definitely for your coming test. So maybe you're taking your first test or second test in your college, so for the coming test this session is going to help you a lot. So I will be sharing with you all the important 2 marks question as well as how you have to answer these questions. When you see these questions in your test, in what way you have to give the explanation, in what way you have to answer. So this is all about today's session. So are you all ready for it? Shall we start today's session, dear students? Yes, quickly we shall start today's session. So when you were studying this chapter, you come across a concept called homologous series. So you can expect a 2 marks question asking you to explain what is homologous series and give example. So students, what is homologous series? First I will tell you. So you know that you take any compound alkanes, alkenes, alkynes or any functional group compound, one compound to other it differs from a CH2 group. For example, if I take ethanol, so first I am writing an example. So give example means whatever I am giving an explanation that you can write as an example. Now see, CH3OH is a first group member of the alcohol family, methanol. And next one, if it is C2H5OH, ethanol. So it goes on like this, right? Methanol, ethanol, propanol. So it goes on. So if you see between methanol and ethanol, what is a common you can find, or what is the relationship, what is the difference you can find? Students, you can find that these two, the difference is these two compounds it differ by one carbon atom and two hydrogen atom, that is it differs in a CH2 unit, right? You take any compound for that matter. For example, methane is CH4, ethane is C2H6 and propane is C3H8. So it goes on like this: methane, ethane, propane, butane. So all this, when you observe all this, you can see each one differ with one carbon and two hydrogen atom, right? So CH2 unit. So this any series of compounds which differ with the CH2 unit, we call it as homologous series. Or in a proper definition, students, we can tell all these are a series of closely related organic compound which can be represented by a general formula, right? Now we have general formula for alkane, that is CnH2n plus 2, and alkene we have general formula CnH2n. How we can come to a general conclusion or a general formula? Because they all differ by CH2 unit. So anything which has a general formula which we can represent by a general formula, and these closely related compounds are known as homologous series. So you write a proper definition and give example as I have explained here. Is that clear, my dear students? Yes, we move on to the next important 2 marks question, that is isomerism. Students, from isomerism concept, in structural isomerism, there are four types, that is chain isomerism, position isomerism, functional isomerism, and metamerism. So out of four isomerism, that is structural isomerism, you can expect any one for 2 marks. So any one out of four, if it is asked, you should be able to answer. So you have to explain what is chain isomerism. After explanation, you have to give one or two example. Fine. Now, when it is asked what is chain isomerism or explain chain isomerism, you have to tell that what do you know what is isomerism, right? Two compounds having same molecular formula but differ in the carbon chain. So students, compounds having same molecular formula but differing in the carbon chain are called chain isomers, and this phenomenon is known as chain isomerism. For example, what is the structure I am writing in front of you? You can see that the structure I am writing in front of you is, can you guess what it is? Yes, students, it is butane, and I will mention it as N-butane. So, N-butane means normal butane. That means it is a straight chain. Now, this N-butane, now observe what is the next compound I write. So, if you observe here, in these two compounds, you see how many carbon atoms are there? 4. And how many hydrogen atoms? 10. Yes, both has the molecular formula C4H10, right? But is this first one is N-butane, right? Second one, is it butane? No, students, it is not butane, it is isobutane, a common name isobutane. Otherwise, it is called as IUPAC. The proper IUPAC name of this compound is 2-methyl propane. So, butane and 2-methyl propane is not the same, but it has same molecular formula. So, chain isomerism means they have same molecular formula, but where they are differing, they're differing in the carbon chain. That means you can see one compound is a straight chain where the other one is a branched chain, right? Same molecular formula but differ in the carbon chain. So this explanation you have to give along with the example. Is that clear? So one will be straight chain, the other will be branched one. Now the same way we move on to the next isomerism, you can expect a question from position isomerism also. So you give a complete explanation for position isomerism. You can tell compounds having, again it is same, compounds having what? Same molecular formula, but position isomerism means they differ in position of functional group. So what will be varying, dear students? They differ in the position of what? Functional group. So this is known as position isomerism. Is that clear? You have to give a proper explanation. And what example you can give? A lot of examples you can give for position isomerism. For example, if you write a simple compound CH3, CH2, CH2OH, this you know it is propanol, and specifically I can mention it as 1-propanol. Whereas if I write the compound as CH3, CHOH, CH3. Students, observe these two examples that I have written. They have same number of carbon atoms, same hydrogen, as well as same number of oxygen. But this is 1-propanol, whereas this one is 2-propanol, right? What is the difference? Same molecular formula, right? The difference is they vary in the position of the OH functional group, right? So this is known as position isomerism. Now, you want me to explain with one more example? Okay, now observe. I've written the compound, you have to try to name it, okay? So what you can observe here, students? Count the number of carbon atoms, number of hydrogen atom, you will see that the molecular formula is same. But here the compound that I have given here is butene. Yes, it is 2-butene because the double bond is in the second carbon atom, whereas this is 1-butene. The double bond is in the first carbon atom. So differ in the functional group, position of the functional group, or the position of double or triple bonds. This is known as position isomerism. So you have to give the explanation, a correct definition, as well as one or two examples. So same way, we shall discuss about functional isomerism. Here, when a question is asked, what is functional isomerism? You will give an explanation as compounds having same molecular formula but different functional groups. This is the explanation you will give. Having same molecular formula but different functional groups is known as functional isomerism. And when an example is asked, you have to be ready to write one or two examples. Now students, look at the example I am writing for you and try to name the compound. So here you can observe one example what I have written. Here is propanol, correct? Aldehyde group is present, so it is propanol, right? Now what is this then? Which functional group is present? Ketone group. So you add the suffix one. So this is propanone. So students, one is aldehyde, propanol, and one more is ketone, propanone. Then what is the difference? Only the functional group is varying, but if you see the formula, the number of carbon is 3, the number of hydrogen is 6, and the oxygen is 1. It is C6H3O, a same molecular formula, right? This is how you have to explain about the functional isomerism. Now, we shall next move on to the last type of isomerism, that is metamerism. So explain metamerism. You will explain that compounds have same molecular formula but differ in the distribution of group on either side of the functional group. That means students, if a one functional group is present, okay, the distribution of groups on the either side, that is the alkyl groups, will vary. That is called metamerism. So let me explain with you an example. For example, if I write a compound, this is the functional group ether, okay, C2H5O, C2H5. So oxygen is between the two alkyl groups. We call it as ether functional group, and we name this compound as ethoxyethane. Now if this is ethoxyethane, students, now see the next example what I am going to write. Here what is happening, this is also a ether functional group, whereas one side you can see here methyl, whereas here you can see propyl alkyl group, correct? So this we call it as methoxypropane. So in the first ether, you can see that on both the sides there is a ethyl group present, that is symmetrical, whereas here one side it is on the functional group, one side it is methyl and the other side it is propyl. So I call it as methoxypropane. Both are completely different compound. They vary in the distribution of the alkyl group, but when you check out the formula, that is molecular formula, both has same molecular formula, that is the number of carbon, hydrogen or oxygen. This is known as metamerism. Is it clear? You give a proper explanation with an example like this for a complete 2 marks. So students, with this teacher app platform, I hope definitely it is going to help you in all the ways, covering all the important questions. So in this session I am discussing all the 2 marks important concepts, and next session also I'll definitely come with the other 3 marks or 5 marks important questions. So please don't miss out the session. Okay. So students, quickly we move on to the next concept. 2 marks question is asked like this: what is homolytic cleavage? Explain with an example. Okay, so they're asking you to explain what is homolytic cleavage. Students, you know that whenever a bond or a covalent bond is present between two atoms, breaking of the covalent bond can happen in 2 ways. One is homolytic cleavage. It is homolytic cleavage can otherwise called as homolysis, and the next one is heterolytic cleavage, otherwise called as heterolysis. Now, homolysis or homolytic cleavage means you can explain it as it is symmetrical breakage of the bond. Cleavage means breaking. So, symmetrical breakage of the bond is known as homolytic cleavage. Okay. In a proper explanation, you can say that when a covalent bond is broken symmetrically, each fragment gets one electron. When a covalent bond is broken symmetrically, each fragment will be getting one electron, and this is known as homolysis or homolytic cleavage. Now, for example, students, what is Cl2? Chlorine molecule. Cl2 is nothing but it is Cl bond Cl, right? So when any photolysis happens on in the presence of sunlight or in the presence of any light, what happens? This covalent bond breaks symmetrically. What is covalent bond? Covalent bond is nothing but it is by sharing of electrons. Two electrons make one covalent bond, right? When a bond is broken, each fragment gets one unpaired electron. This gets one electron, this will get one electron, and like this. So after breaking, Cl1 Cl is getting one electron, the another one is getting one electron. So that is one electron, or we call it as unpaired electron. Is that clear? Unpaired electron. So this way of breaking of the bond is known as homolytic cleavage. Okay, symmetrical breakage of the bond so that each fragment gets one electron is known as homolytic cleavage. Now what is this chloride ion with one electron? What is this fragment with one single electron or unpaired electron called? This is called as free radical, my dear students. Okay, so once you are done with homolytic cleavage, the next question they can ask you, what are free radicals? So I will definitely explain you about it. Before that, let us understand the next type of breaking of the bond or the cleavage of the bond, that is heterolytic cleavage. So this concept also you can explain, or 2 marks you can expect, that is what is heterolytic cleavage, explain with an example. So heterolytic cleavage or heterolysis is an opposite of homolysis. So here what happens is, now for example, if I have taken a compound like chloromethane, a bond present between CH3 and Cl. Here, when a covalent bond is broken, it is broken unsymmetrically. Homolysis means symmetrical, whereas heterolysis means unsymmetrical breaking of the bond. So, here what happens when unsymmetrical cleavage is taking place? Either both the electrons in the covalent bond will go towards one fragment. Anyway, it can happen based on which is more electronegative. Okay, either both the electron may go towards one fragment, or it is completely depending on whether in both the fragment which one is highly electronegative. There the both electrons will be attracted, or if it is if I just take it as in general X, both the electron can go towards carbon also. So it is completely based on which is more electronegative. So it is an unsymmetrical distribution of the electrons is known as heterolytic cleavage. And when this heterolytic cleavage happens, you can explain it and give a proper example as I have explained to you. When it happens, what happens if both the electrons are going towards Cl, so Cl is accepting the electron and it becomes Cl minus, negatively charged. After breaking, CH3 methyl group will acquire positive charge, right? Because it lost the electrons, so it acquires positive charge. In case if both the electrons are moving towards CH3, then the CH3 group gets the negative charge, whereas the another substituent, that is X, acquires the positive charge because it lost the electron. Is it clear, students? Now, when the CH3 methyl group is positively charged, you can see a positive charge on the carbon atom. If you can observe a positive charge on the carbon atom, this is known as carbocation. Okay. And if you can observe a negative charge on the carbon atom, then this is known as carb anion. More about this we will study in the further question. Okay. So now once you have understood homolysis and heterolysis, what is the intermediates you are getting from homolysis and heterolysis? I told you, right, that free radicals, the term free radical, carbocation or carbanion, these are known as intermediates, students. Okay, so with this intermediates also, about this intermediate you can expect 2 marks question. What are free radicals? What are carbocations, or what are carbanions? So like this you can expect 2 marks question from the intermediates part also. Okay, so what are free radicals? So an atom or a group of atoms containing an unpaired electron obtained by homolysis of a covalent bond is known as free radicals. You understood how free radicals is formed? By homolysis, any fragment, if it is having an unpaired electron, we call it as a free radical. You understood that? That you put in a proper sentence. Okay, an atom, it can be, or a group of atoms containing an unpaired electron. How it is containing a single electron or unpaired electron? Through a homolytic cleavage is known as free radical. Okay, so explain its stability is the next question, 1 mark question. What explanation you give for free radical carries 1 mark. They can ask you to give examples or to explain the stability. Now students, listen. If I write it as CH3 CH2 Cl. Now here a bond breaks and both the electrons go towards chlorine, then what you get here is CH3 CH2 free radical, right? So sorry, free radical. Just a minute, see here what happens. Symmetrical cleavage, so you get one single electron on the chloride ion and one electron on the CH2 group. So one electron here. So here the CH2 group, which is carrying one unpaired electron, is further attached to how many alkyl group? 1. So students, this is called as primary free radical. Okay, so this is called as, in short I have written like this, or primary free radical. Now if a compound is like this, that is isochloride, here the cleavage happens, symmetrical cleavage, you can expect a free radical like this. The unpaired electron on the middle carbon, on the CH carbon. Now what is this called? This is called as secondary free radical. Students, secondary free radical means carbon atom, you see that if the carbon atom containing an unpaired electron is further attached to two alkyl groups on the left and right? Carbon atom containing unpaired electron is further attached to one alkyl group, it is primary. If the carbon atom containing unpaired electron is further attached to two alkyl group, it is secondary. Same way, the next one I am going to write like this. Here the carbon atom which is containing the unpaired electron is further attached to three alkyl groups, you can observe, right? So this is tertiary free radical. Okay, so free radical can be further classified as primary, secondary and tertiary free radical, students. In that which is more stable, it is always tertiary is more stable than secondary, and secondary is more stable than primary. So I can write like this: tertiary free radical is more stable than secondary, and secondary is more stable than primary. So when it is asked to explain the stability, you write primary, secondary and tertiary structure of free radical, and you write in a increasing order which is more stable. And students, also one more point you have to know: when stability, if you know, the reactivity is opposite of stability. Stable andre always the compound will be stable as such, it is not much reactive. Any other disturbance outside, it keeps itself stabilized, it is not much reactive. Whereas reactivity means it is opposite. Primary is highly reactive than secondary, and secondary is highly reactive than tertiary. This is about the reactivity of the free radicals. Okay, reactivity is always the opposite of the stability. Okay, now same way, you know what is carbocation? I told you, heterolytic cleavage, if both the electrons is going towards one atom and the carbon with which lose the electron will get a positive charge, and we call it as carbocation, right? Now, so when a question is asked what is carbocation, you can tell a group of atoms containing a carbon atom bearing a positive charge on it is called carbocation. So I can write carbocation also as CH3, CH2. If positive charge on this carbon atom on the CH2 group, if it is further attached to one methyl group, then this, students, this is called as primary carbocation. Okay, primary. You know how the carbocation is formed? I explained in the heterolytic cleavage, right? So now, so the definition you will write that a atom or a group of atom bearing a positive charge on the carbocation is known as carbocation. Now this is secondary carbocation, where you can see that the carbon carrying positive charge is further attached to two alkyl groups, and the next I can write tertiary carbocation in this way. The carbon here that is carrying positive charge is further attached to three alkyl groups. So this is tertiary carbocation, students. So you write primary, secondary and tertiary structure of carbocation, and when they are asked to explain the stability, you can say that in the carbocations as well, tertiary is more stable than secondary, and secondary is more stable than primary. So why tertiary is more stable here? Because you can see that the tertiary carbocation is further attached to three alkyl groups, correct? All the three are bulky groups here, students. Okay, when there is so heavy groups on it or a bulky groups, it cannot react very fast with the incoming nucleophile or incoming any groups, because it is already carrying three bulky groups. It cannot easily or fast, very fast it cannot react, so we say that it is highly stable. Therefore when it comes to reactivity, we say that primary is more reactive than secondary and secondary is more reactive than tertiary when it comes to reactivity, because primary doesn't contain much bulky groups, it contains only one alkyl group, so easily it can undergo reaction. So this is the way of explaining the stability as well as reactivity. Now once you have understood about free radicals and carbocation, the next is carb anion. Right? So carb anion means during heterolytic cleavage, you can say that an atom or a group of atoms bearing negative charge on the carbon atom after heterolytic cleavage, if a carbon atom is getting negative charge, we call it as carb anion. Right? So carb anion also, students, we can write the same way how you written for carbocation. The same way you can write primary, secondary and tertiary structure of carb anion. This is secondary, and also this is tertiary structure of carb anion. So this is primary carbanion, this is secondary carbanion. Now you understood, right? This is tertiary carbanion. Now here when it is asked to explain the stability, here there is a change, students. In carbanion, primary carbanion is more stable than secondary, and secondary carbanion is more stable than tertiary. Got it? So the stability of carbanion goes like this: primary, that is completely opposite of the carbocation. So give an explanation of a proper definition of carbanion, and then you explain its stability. Okay. So with this, we cleared a concept of how a covalent bond is broken. A breaking of a covalent bond between two different elements or two different groups can happen in two ways. One is homolysis, one is heterolysis. Homolytic cleavage means equal distribution of electron, and on equal distribution, each fragment gets an unpaired electron or a single electron, and they are known as free radicals. Whereas heterolytic cleavage means when a carbon atom bears positive charge after heterolytic cleavage, we call it as carbocation, and when a carbon atom bears negative charge after heterolytic cleavage, we call it as carb anion. In the carbocation, carb anion or free radicals, we can write primary, secondary and tertiary structure of them, and we need to explain its stability and reactivity. So if you know all this concept will be very much clear to you. Okay. Now, since we are studying all the basic things necessary, as the name of the chapter says, we are studying all the basic things necessary for organic chemistry. There are question that is asked for 2 marks. What are electrophiles? Give example. So I think this term is new for you. What is the meaning of electrophile? See, students, we can call this as electrophiles are a compound or a group of atom which is electrophilic in nature. We can call it otherwise as electrophilic. So what is this? The term philes or electrophilic, love towards electrons. In a simple way I'm telling. See, electro means electron, love towards electron, we call it as electrophiles. Philic, hydrophilic means love towards water, phobic means hatred towards water, correct? Like that, electrophiles means electron loving species, we call it as electrophiles. Students, this I just told you to understand the concept. The exact way you can tell, see, if they are electron loving species means they have deficiency of electron. Now whatever deficiency you have, anything you don't have with you, then you will show more love towards that, right? You will try to get that. If you're not having, you will always show interest, or you will be waiting to have that, correct? So you are showing so much love, and once you get a chance you will definitely grab it, correct? So electrophiles are like that. They are electron loving species. Once an electron comes near it, it will attract towards it, it will grab the electron, because it is electron deficient species. So electron deficiency means definitely they should have what charge on them? They should have positive charge on them, because they'll deficiency of electrons, right? So they will be having positive charge on them. Whatever I explain, you put it in a proper words and write the explanation for electrophiles. Electrophiles are electron deficient species which are attracted towards electron rich center. Understood, students? Electrophiles are electron deficient species. They do not have much electron that is required. So when they are electron deficient, what they do, they attract towards electron rich center. For example, so they are carrying positive charge, like it can be H plus or Cl plus or nitro group NO2 plus. So students, you can see all these compounds is carrying positive charge on them, so they are electrophiles. Or in a simple way, any compound is given, how do you identify it as electrophile? Is it is carrying a positive charge on it, so it is an electrophile. It is deficient of electrons, therefore any electron comes nearby, it will try to grab it. Is that clear? Then what is this nucleophiles? Nucleophiles, you can see, tell that, or you can understand, they are electron rich species. Is that clear? The exact opposite of electrophiles. Nucleo means here. So you can say nucleo means what? Nucleo means nucleus. Philes means what I told, loving. So nucleus loving, correct? So nucleus loving means they are already electron rich species. They love towards the nucleus that is a positive charge. They have more and more electrons on them. Already they have electrons. That means what is the charge on them? Already they have electrons means the charge on them will be, yes, the charge on them will be negative charge. So it can donate electrons. What is the nature of, since it is negative charge, its nature will be like it can donate electrons to anyone which is coming with a deficiency of electron. Now if an electrophile comes which is having a electron deficiency, this nucleophile can donate the electron. Is that clear? Because it is rich in electron. So how I can put this in a proper sentence? I can tell that those electron rich species which are attracted towards electron deficient center, or I can tell the electron rich species which is able to donate electrons to electron deficient species are called as nucleophiles. So you can write a number of example like Cl minus, Br minus, or OH minus, or Cn minus. These are the electron rich species. See, negative charge on them, which can donate electrons to electrophiles. Is it clear, my dear students? So in today's session we discussed a lot many 2 marks questions that is asked from the chapter organic chemistry, some basic principles and techniques. What is homologous series, what is chain isomerism, what is position isomerism, what is functional isomerism, metamerism. Also we understood two types of cleavage, homolysis or homolytic cleavage, heterolysis or heterolytic cleavage, what are free radicals and the stability of them, carbocation and its stability, carb anion and its stability. Also finally we understood the definition of electrophiles and nucleophiles along with the proper example. Right? So students, I hope this session is definitely helping you, because in the coming months you will be facing tests, correct? Tests or exams, and from this chapter whatever questions we discussed in session you can expect, definitely you can expect. Okay, so go through, once you have gone through this session, take down the screenshots of it, go through the definition in your textbooks and also the examples you practice, students. Next session I'll definitely come with the next set of questions, can be 3 marks or 5 marks, next set of important questions. So I hope this session helped you a lot. So thank you all for being with me. Thank you all for listening to the session.